Okay, students, so we'll be beginning our course with the first chapter in chemistry. So the first chapter in chemistry, it is your chemical reactions and equations. So this whole chapter basically is the theoretical form of whatever you have got in practicals in class 9. So whenever we talk about a chemical reaction involves a chemical change. And you have studied in class 9 that chemical changes are those changes where basically there is a kind of permanent change. Most of the chemical changes are permanent changes and there is a change in the chemical properties. That is the main definition of chemical change, that there will be change in the chemical properties of the substance. For example, you take a piece of paper and you burn it out, you end up getting ash. So the properties will change. So how do we know or come to know that a chemical reaction is taking place? So whenever you observe any chemical change taking place, it will have some features, and based on those features we can come to know that chemical reaction is taking place. So here I have listed some features, like for example evolution of gas. So you have seen, suppose we put a Disprin tablet into water, you'll find bubbles coming out, right? So like that, in some reactions you'll find there will be evolution of gas. For example, suppose we take some zinc granules. Zinc metal is silver color and the zinc granule looks like cornflakes. So you take a piece of zinc and you drop it in hydrochloric acid, dilute hydrochloric acid. What you will find that there is rapid effervescence or bubbling of some gases. What is that gas? The solution that will be formed is zinc chloride, and the gas which will be evolved, it will be of hydrogen gas. So you will find some rapid bubbles coming out. Now if you can close the mouth of the test tube with your finger and bring a burning mastic, you open the thumb and you put the mastic into that test tube, that gas will burn with a popping sound. So that is the characteristics of hydrogen gas, that it burns with a blue flame and pop sound. So this is an example of evolution of gas. Next is formation of precipitate. There are certain reactions where when there will be a chemical reaction between the two reacting substances, one of the product which will be formed, that product will be solid and it will settle down. For example, suppose we have the reaction between barium chloride and sodium sulfate. This example was given in your fourth chapter in last year. It was given in the laws of chemical combination. In that part it was given, so you can refer that. So when these two substances, now this is also a colorless aqueous solution, there is also a colorless aqueous solution. Now when you react it, you will find that there is a chalk, white chalk like precipitate or a substance which is formed. And why it is so? It is due to formation of barium sulfate. So this barium sulfate is the white precipitate. Along with it, you'll get a solution of sodium chloride. The next feature which you can observe in a chemical reaction is change in temperature. Change in temperature can be of two types. There are some, suppose you burn a mastic, heat will be given out. You burn a magnesium ribbon. Burning of magnesium ribbon we have all seen during Diwali when we burn the sparkles. Then the sparks which comes out from the sparkle is due to magnesium ribbon. So when you burn magnesium ribbon, it will react with oxygen, so it will form magnesium oxide plus heat will be evolved. So such kind of reaction where there is evolution of heat, these are called exothermic reaction. Exo means out and thermic means heat, so heat is given out. Now there are certain other reactions, like an example of reaction between nitrogen and hydrogen for formation of ammonia gas. Now these two gases easily do not react. So you have to supply a lot of heat. A lot of heat has to be given in. So such kind of reactions are called endothermic reaction. Endo means to provide. Then there might be change in color. You have seen rusting of iron in day-to-day example. So whatever chemical changes are occurring in your day-to-day surrounding, that also you can observe, or chemical examples also can be given. For example, like your teacher must have shown you in lab last year, that when we take a blue color solution of copper sulfate and in this we put some iron nails, so there is a blue color aqueous solution, AQ. What I am writing here is AQ, aqueous. So blue color aqueous solution, we are adding iron nails. After some time we'll find that the iron nails gets covered with a reddish color surrounding. Why it happens? Because iron is more reactive than copper, so iron will be removing copper and you will get the blue color solution will change into pale green color and you will get reddish deposit of copper. So this is an example of change in color. Then there might be change of state. For example, like if we are reacting hydrogen plus oxygen, both are gases, but we end up getting what? We end up getting water, which is a liquid substance, which is in a liquid state. So any kind of chemical reaction, it might show all these properties or few of these properties. In a chemical reaction, you might find 2 or 3 properties being expressed, but at least one of these properties will be there. So that is the first part we are discussing. The next thing is, when we write any kind of chemical reaction is represented by an equation. All these that I am writing here, these are all equations. So when we write an equation, here there are some examples. Every equation has got 2 parts. The left side of the equation, it is called the reactants, and the right side of the equation, these are called the products. Now the next thing that we are going to learn is balancing of chemical equation. Balancing means where the total number of atoms on the reactant side should be equal to the total number of atoms present on the product side. That is called balancing of reaction. Now how or why we need to balance? First we have to learn that. Suppose here I have taken one example, hydrogen plus oxygen gives us water. So how many hydrogen atoms are there? 2 here, 2 hydrogen atoms here. Here there are oxygen, 2 atoms are there. Here 1 oxygen atom is there. So oxygen is unbalanced. So we need to balance this oxygen. How we can balance it? We have to make this oxygen 2. How will we do it? So we can place a 2 here, but no. If we are placing a 2 here, the formula will become H2O2, but the formula of water is what? H2O. So you cannot place a 2 here. Neither you can place a 2 in between, because formula of water is H2O. So what will happen? The formula will change. So the only place where you can place a 2 is in front of this. So as you are placing the 2 here, what will happen? This 2 gets multiplied with the whole molecule. So oxygen becomes 2, but at the same time hydrogen is becoming 4. 2 2s are 4, because 2 is getting multiplied with the whole molecule. So you again come back to this side, because now hydrogen gets imbalanced. It has become 4 here, here it is 2. So you need to balance hydrogen. So what we'll do? We'll place a 2 here. So this is how balancing needs to be done. So an unbalanced chemical equation is called a skeletal equation. So skeletal equation is unbalanced equation. Why we need to balance it? So that the equation follows the law of conservation of mass. I'll show you here. Suppose H2 plus O2 gives us water. If it is unbalanced, what will be the mass? Here it is 2. Here it is 16 into 2, that is 32. And this side it is 2 plus 16. So here it is 34. Here this side it is 18. So it is not getting balanced. So any equation should always follow the law of conservation of mass. Now if we are balancing it in this condition, so we have 2H2 plus O2 plus gives us 2H2O. Now let us see. 2H2 means 2 2s are 4. Plus 16 into 2, that is your 32. This side 2 into 2 plus 16. So 32 plus 4 is your 36. And this side also 16 plus 2 is 18. 18 into 2 is 36. So it is balanced. So now it is following the law of conservation of mass. This is the reason why we need to balance a skeletal equation. So this is one way of balancing. Another system that you can follow. Now all this is called trial and error method. Why trial and error method? Because we are not applying any formula for balancing. We are trying. First we will look at both the sides, and by looking at both the sides we have to balance it. So you try. If it is not getting balanced, then you go to the next one, that way. So it is called trial and error method. There are formula based method, but that is for your higher classes. Now we come to this example. N2 plus H2 gives you NH3, ammonia. There is ammonia gas. So here nitrogen is 2, here nitrogen is 1. In order to balance nitrogen, what I do here? I place a 2 here. So the moment I place a 2 here, it gets multiplied with this whole molecule. So 2 3s are 6. Now hydrogen becomes 6. So now we come back to hydrogen. Hydrogen is 2 here. How do we make it 6? We take the multiple, that is here 3. We place a 3 here, 3 2s are 6. Now it is not that all equation needs to get balanced. Now let us have a look at this. This is the reaction between quicklime, hukansun बोली जाए कोई, सूखा चूना के साथ हम लोग पानी मिला देते हैं. So the moment we add water with quicklime, you will find bubbles coming out, heat is being evolved. So it's an exothermic reaction, highly exothermic reaction. And the product which is formed is called slaked lime. The lime which is used for whitewashing, or it is applied on betel nuts, betel leaves. So here you see calcium is 1, here calcium is 1. Now this bracket is there, so bracket or bahirat ase 2. So there is a 2 outside, so oxygen is 2. So this side, on the reactant side, here we have 1 oxygen, here we have 1 oxygen. So oxygen is also balanced. Hydrogen here we are having 2, hydrogen here it is 2. So this equation is already balanced, so we don't have to balance this. Another one example we can take is that sometimes we find that a radical is as same as on both the sides. For example, suppose lead nitrate plus sodium sulfate, this side is lead sulfate and sodium nitrate. Now what we see here NO3 as a whole is 2. So you don't have to take it separately as nitrogen and oxygen and balance it separately. You take NO3 as a whole. Now this can be applied only when this side also there is the same NO3. So here there is NO3, how many NO3 is there? 2. Here as a whole NO3, how many it is there? 1. So what we do, we have to balance this 2, here it is 1, so we place a 2 in front. So sodium is becoming, the moment we put 2 here, sodium becomes 2. So this side sodium is already 2. Here sulfate as a whole, sulfate SO4 is 1. This side also SO4, it is 1 group. So it is already balanced. So this is how we can balance if the radical is present as it is. But if the radical breaks up, suppose this example, lead nitrate. Here NO3 is there, but this side there is no NO3, it has become NO2. Under this condition, you have to take nitrogen separately and balance it, and oxygen separately and balance it. This I have given as a task for you. So this is how basically we balance chemical equation with the help of trial and error method. So in this page, I have some work for you. So these are the equations. You will try to balance these equations and complete it. Thank you.